why we need computers? We have humans to interact with. Why do we need machines?
So it's just the real world, right? It's very messy and unpredictable. We can be very diligent about how we get our models ready, how we test them, the quality of data, all of those things.
Hey Sairam, good morning. Welcome to Latency and Latte. I know you are a morning person. Your brain is probably miles ahead of mine already. And I'll do my best to keep up with your energy here.
To be honest, I mean, the caffeine is just kicking in, so we'll see. We'll see. I think we might be at the same level for which might actually help with the conversation. So we'll see.
Yeah, awesome. So you have worked across Qualcomm, Intel, NASA, and now Valeo. That's quite a lineup. So let's start simple here. What's first pulled you into AI? Was it a specific project or just out of curiosity, or you were thinking about some problem that refused to leave your head?
So actually, what pulled me into AI is photography, which is very strange. It has nothing to do with any of these companies. And when I was a kid, these were the film camera days. I used to like taking a lot of pictures, and film wasn't cheap. It used to
Yeah.
cost a lot, and then you had to give it to the labs to develop and everything. I was fascinated with that, and then along the way, I found that there was ways to manipulate the images, like you could add sharpness to them, and all of those things. The entire field was called image processing, and then there's a larger area of that called signal processing, which was kind of the thing I ended up studying in college. And along that path, I found that not only could you manipulate images, you could actually teach computers to understand images, and that's when I was hooked. And then since then, I've been, deeply involved in computer vision, and then that was my entryway into AI, and then LLMs came along, so NLP, and the rest is history.
Very interesting. Yeah, so photography and art demand a keen eye for, detail and composition. So I imagine that visual intuition helps when you are architecting models that must pass, complex scenes here. So do you find your creative work informs your AI problem solving in surprising ways?
I think it's bi-directional, to be honest. So what happens usually as a photographer, you spend a lot of time trying to remove things from your picture. It's like the art of subtraction, and often things look fantastic in when we see it in person because it's three dimensional. Our eyes are able to capture depth,
Mhm.
perception, like the put together, like how the scene is in 3D, and all of that happens rapidly.
Yeah.
When we take a picture, all of that is collapsed into a 2D canvas, and the moment that happens, depth is gone, perspective is gone. So then you have to use tricks like how do you keep the objects in the foreground closer to you, or that way they look bigger and then the object in the background looks smaller. So that gives you, like, for example, if a mountain is smaller than say a flower or something in your picture, that immediately tells your brain something is up, because a mountain in real life is no way smaller than a flower. But that perspective trick gives you the sense of depth, right? There's like all of these cues. So what I try to see is, like, when I'm trying to train AI models or collect data for training AI models, I try to see if the data is giving me those kinds of cues. Because if
Yes.
I can't tell the difference between the depth or the perspective, chances are that a model that has no idea of any of this context, it's going to be able to do it easily. That's how sort of photography has helped me inform projects that I work on. It helps me identify corner cases, to be very clear. And the reverse is that because I know that these are the limitations of the medium, I'm actually more careful about trying to find them out in nature and so on. So that's the way they work together.
Awesome. And now I'm curious, how those creative instincts connect with your AI work here. And that's awesome to know the background. Creativity really does fuel innovation, especially in fields, in field as a visual, as a computer vision, right? So just for fun here, AI can now write, draw,
Hmm.
even drive also. So what do you think still makes human irreplaceable here?
The thing that I keep coming back to is taste,
Mhm.
because AI is now, see, everybody has access to these tools, and it's really scary and amazing at the same time.
Yeah.
Like people who had to travel miles and miles to a different country to go and take a picture of a particular place can now sit at their computer and prompt it and then have a visually appealing image come out. But it's not the same. It's not the same as actually being there and actually taking all of this in. From an emotional perspective, there's a sense of connection that is lost. But from sort of a creative perspective, why do you need the humans in? It's because of taste. Because if everyone produces the same output, then the
Yeah,
differentiator is who can actually add aesthetic value. Like what is good from great, the difference is really taste. So
right.
that's where the human steps in, whether it's writing, whether it's creating art, whether it's even developing software, which requires a lot of, I mean, we can talk about vibe coding and how it's empowered a lot of people, which is awesome. But
Yeah,
the truth is, good software engineering principles have never been in more demand than
yeah,
today. And that also, in a sense, is taste, is like preferences, and
yeah.
that's the differentiator, in my opinion.
Absolutely, and completely agree here. Empathy, intuition, and I would say some soft skills, creative thinking,
Yeah.
and those are going everywhere.
I keep telling people, like, if you're worried about manager jobs or those kinds of things going away, those might reduce, because obviously AI is able to do a lot of things more efficiently and at scale. Plus, it doesn't need food or water, right? But I keep asking, like, this is something that one of my friends asked me, and it really stuck with me. It's like, would you rather have your one-on-one with a machine or a human?
Yeah,
And
absolutely.
I know the answer for me.
Yeah, yeah, absolutely. And this is a great start, Sairam. It's interesting how often a single challenge or curiosity can set the whole career path from photography to AI. And I guess once you dive in, the layers just keep unfolding here. And the companies you have been worked so far has been very different, from the
Hmm.
space to cars. Now I'm curious, what's been consistent in how you think about AI through all those transitions?
I so To be honest, there's always been an element of luck. I think in everybody's career, there's a element of luck that guides you towards one role and then to the next and so on. So in my case, the common thread is beyond this point. This element of luck, I feel like the common thread is a desire to learn new things.
Hmm.
When I started at Qualcomm, the focus was on mobile AI, right? Everything had to be done on device, whether it was phones or tablets. And that was a completely different challenge, because you are like, those constraints really force you to think creatively. And then around the time, that's when deep learning started taking off. And I wanted to have the opportunity to work with and train these models. And these were large models at the time. So if you look at them now, they're tiny models, but at the time, they were like, this is a pretty big deal. So I moved to Intel because I had the opportunity to work with deep neural networks. And then along the way, I had a 20% project. So that's how my collaboration with NASA and the Frontier Development Lab happened,
Hmm.
which is, if you could apply AI to help understand our sun, that sounded like a fantastic opportunity. Another learning opportunity about how you can apply AI to something that's much bigger than any of these problems that we look at on a day-to-day basis. And then from there on, then autonomous vehicles, again, this is another sector, right? So now we have all these large models and everything available to us. How do we again go back to actually having them run on cars? But then there's another element. You have to make split second decisions. There's safety involved. You have to be very careful about what you put out into the world, because millions of people will use it, and the margin for error is less. So at every stage of the process, our journey, for me, it's been, what am I going to learn? And when that learning stops, what's next? That's always been the common thread.
Yeah.
So it's not really about AI, but it is about AI.
Yeah, absolutely. And it's interesting, sounds like your mental model of AI evolved less around the specific tech stack and more around understanding uncertainty, data quality, and, system robustness. So those fundamentals, I believe they do not change no matter, regardless of the domain. I mean, the fundamentals are still there. And
Yeah, I
if
mean,
I,
like,
yeah,
fundamentals over the fancy frameworks. That's always my that's always what
absolutely.
I look for. Yeah.
Absolutely. And if a 10-year-old asked, what do you do at work? So without using the word algorithm, how would you explain it?
So I'd probably say, by day I teach computers to understand us,
Mhm.
like through pictures and words, and by night I teach humans to understand the computers. So
That's a very good thought. Yeah, I know. Even my 8-year-old, she keeps asking me about why we need computers. We have humans to interact with. Why do we need machines?
see, that's a smart person right there.
I was clueless. I'm like, I need to find an answer why we need machines.
It's an amazing question, to be honest. It's like, as soon as you said it, I was thinking about, wow, that's a really deep question.
Yeah, and my husband
Need
and
to
I, we
think
were
about it.
brainstorming. Now AI is coming. There is another artificial intelligence, and her question was very simple. We have a
Hmm.
natural intelligence, so why we need to make it artificial? And we were like stumble upon that question, and we were like, okay, let's find it out.
Wonderful question.
Yeah, so that's actually perfect. And even if you can explain kid about the algorithm and machine, and maybe you have mastered it, that's the difficult part to take care of it, I believe. And yeah,
I would actually say the difficult part that I've seen is communication,
yeah,
especially across different stakeholders. And I know I'm using like jargon like stakeholders here, but the point is like
yeah,
people come from different backgrounds and perspectives, and having a good translator in the middle is like a unifier, because otherwise everybody is going to be explaining the same thing from their perspective, probably end up in circles, and at work you end up choosing the wrong initiatives to pursue. So
yeah.
having just somebody who's the glue in the middle, who can communicate these or bring the common language, like that makes a big difference. So yeah,
Mm,
that's yeah,
absolutely.
yeah.
Yeah. So you have spent years bridging research and production systems, and you often say you focus on AI that actually ships. A
Mm,
lot of AI looks great in papers or demos, but then breaks in production when you
mm.
actually start shipping that. So, what usually causes that gap between theory and practice here?
So it's just the real world, right? It's very messy and unpredictable. We can be very diligent about how we get our models ready, how we test them, the quality of data, all of those things. And yet there will be a corner case that hits you on the head. It's just the way life works. And so having that paranoia to be thorough and be careful when you're designing, being intentional, testing thoroughly, or doing all of that ahead of time, it just reduces the intensity of the real world. There's all kinds of things that can go wrong, and you probably wouldn't have thought of it because it's very challenging, right? Any real world AI problem is challenging. So I feel like that is the main reason. The other
Mm,
reason is I feel sometimes maybe you don't need to use AI. It's like that
yeah,
there might be problems where simple heuristics, or you already have a traditional method that works more than well enough for your needs. But then
right.
the moment you artificially try to attach AI into the thing because it's good for marketing, or it's good for fundraising or something like that, that's when things start falling apart. So
Right, right.
those
Absolutely.
those would be my answers.
Yeah, and I'm guessing things like latency constraints, edge cases, and distribution shifts are some of the biggest hurdles here. And how
Yeah,
do you usually tackle those, Saira?
I think it depends on the problem. To
Mm,
be honest, we talked about mobile devices and autonomous vehicles, right? There you are severely constrained by the computation available to you. So it's usually like either a phone or a car or a tablet.
mhm.
And those are
Right,
very, like, even though a car is a huge device, you have to understand that the the battery is powering a lot of things, not just the processing. And
right,
the compute availability, the CPU, GPU, all of that availability is like a fraction of what will be available in, say, a cloud based system like a server farm. So then your constraints are immediately, your design decisions immediately go towards prioritizing latency, because you have to make sure the decisions are made in a timely manner. And
right.
then on top of that, if it's like an autonomous vehicle problem, then you have to prioritize safety. So accuracy, I say accuracy, but there are a number of other metrics that has to
Right.
be the forefront, because you cannot afford a high incidence of false positives or poor decisions. And
Right.
then if on the other hand, if this is like, say, a recommendation system that's working in the cloud, the problem is like you have to keep the model current. This is just one of the examples. There are many more situations, but imagine, like, I like to give this example a lot. Imagine a recommendation model that was trained right before the pandemic. It would
Yeah.
have no idea about the need for the uptick in masks or the uptick in those hand wipes. So if you use that model without updating it, without accounting for the data shift and the trends, seasonality, all of those, then it's a useless model. So those are just things that you have to, I guess, like in any AI problem, launching is one hard problem,
Yeah.
launching the right solution. But then the second problem comes after you had a successful launch, which is maintaining, because more people want to use it. And on
Mm,
top of that, like you said, there's latency constraints, there's data shifts, there's so many other things that come into the picture, and
yeah.
maintaining it intentionally, right? That is the second part of the challenge.
True, absolutely. And when we talk about the perception systems in autonomous driving here, it's not just about spotting a stop sign, but it's more about the scene, who's moving, and what's about to happen, and what is the safe to do the next. So, how close are we here to that level of real scene understanding today?
I probably can't give the full picture, to be honest, because there's a lot of amazing research happening in parallel, as is the case with AI. Every day there's something coming up.
Yeah.
But if you just observe how things have evolved, like you can see that previously we needed a lot of these sensors, right? And we could actually see them physically attached to the vehicles, like these bulky sensors to make sure things were happening. Nowadays, you're seeing more and more cars where it doesn't look so different from your traditional non-autonomous car, but then it's
Right.
able to drive from point A to point B. Like Waymo is an example where they're able to deploy taxis in certain cities, right? And then the other thing that you notice is that the quality of the algorithms powering them has also gone up. Like with more data, with better algorithm design, all of a sudden the vehicle's able to bring in a lot of context. So it's easy to say, okay, yeah, the car has to see the traffic signs, ground markings. If it's parking, it should know where the parking spots are, the sidewalk. But then there's so many things that all have to be fused together to make a meaningful decision, and then on top of that, plan the path from wherever the car is to wherever it needs to go. So that is always a hard problem. And my feeling is that there's still a ways to go in terms of problems to really become fully autonomous.
Yeah, yeah, absolutely. And context is everything here, and it's crazy how to do this intuitively.
Yeah.
Yeah, and how do you approach building models that can reason about those subtle cues? I mean, you have built AI for both cars and space. So, two worlds with opposite data challenges. So, which one pushed your team harder technically?
So definitely the space one for two reasons. One, when you work on such a problem, you realize how insignificant you are. That's
Yeah,
the first thing.
yeah,
Because some of the problems that these scientists are trying to understand is like, okay, is a solar flare from the sun going to disrupt communications, and how far in advance should we be able to forecast it? And then the data sources for them are satellites, and the satellites are not always ideally positioned. And then the particular view of the sun, for example, that they're trying to capture may not always be available because planets are moving, the sun is. And then on top of that, you have noise from each of these capture devices. And then there's only so close you can go to the sun before things burn out. So
right,
then it just keeps adding on. And then on top of that, the other aspect which is very interesting is explainability, because a lot of these models, they do hallucinate, right?
right,
And a very strong question that came from a physics expert in during one of these projects was, how can I trust your model's prediction? How do I
right,
know it's actually not imagining things? And
right.
because for them that interpretability is crucial, but that's how they sort of make
Yeah,
decisions downstream. And when you can't guarantee that, it just they trust it less, and then they go towards methods that are more explainable for them. And that's the right way to look at it. So that for me is the harder challenge compared to some of the problems we do here on a day-to-day basis, because your data is noisy, your ground truth is almost impossible to get at a reasonable cadence, the feedback loops are slower, so that makes it a much harder problem.
absolutely. And that's fascinating also, totally different constraints, but how both force creative problem solving here in
Yeah.
space and car. Let's pause here for a moment and just to ground the basic of people listening skills. When we teach a car to see, we are not talking about giving it eyes like a humans, but
Hmm.
it's more about the neural networks make sense of raw pixels to detect shapes, motion, depth, and context sometimes.
Hmm.
So that's quite messy environment here. So this is where perception pipelines come in, and now we have got cameras are there and all those feeding models that fuse signals across all the modalities. So
Hmm.
from your perspective, there are a lot of nuances here. What's the change the most of how we teach these systems over the past 5 years?
I think the shift has been more on the architecture side, to be honest, because early part of computer vision, at least this is my experience, is
Yeah,
computer vision and AI has been around since like decades ago. So I don't want to make it sound like we invented something brand new.
yeah,
But the early part, pre deep learning, it was always about feature engineering and identifying the interesting parts of the scene ourselves, and then having models try to use that. So you're kind of spoon feeding the model a little bit, and the
right,
volume of data you needed to do that was orders of magnitude lesser compared to what we need now. And then during the initial deep learning era, it was like CNNs, right? So you sort of have to feed a lot of data. Like ImageNet, for example, has millions of images,
yeah,
and then the model would then learn from that data, and the performance was an order of magnitude better. I'm not saying that we can't hand tune traditional approaches for certain problems. In general, the performance of neural nets, CNNs, was much better. And then
Right.
if you fast forward a little bit more, 2017, Attention Is All You Need came out, and then everyone started using transformers for language. And the interesting bit is there's been cross pollination on both sides. So the whole notion of transfer learning, which is the ability to fine tune a model on new data based on like with a small amount of new data, based on the fact that it's already seen a large amount of data in another problem. That concept was first started, at least as far as I understand, in computer vision. That moved over to language models, and then that's how we had all of these explosive breakthroughs, because then you could pre-train on a large corpus like Wikipedia and all of that, but then you could fine tune on your domain specific data set, which
Yeah.
made these models more valuable. And then
Mm.
transformers all of a sudden then found their way back to vision. So you had the
Yeah.
vision transformer come out. You also had like parts of the transformer being used in context in addition with convolutions, like you can use cross attention, those kinds of things. So there's been a lot of architectural innovations that I've observed.
Yeah.
From the data side, I think we've become a lot more wiser in terms of what is needed, the volume of data, the ability to capture it. And then if you look at the training perspective, just being able to train more efficiently, scale these models, I feel like those are the primary changes. So
Yeah. Yeah.
I might be
Absolutely.
missing something really obvious here, but those are the changes that come to mind.
100%. And you're spot on here. The funny thing is that we talk about model architecture, but the real evolution happened in data here and tooling probably. And let's talk about your book, AI
Sure.
for the Rest of Us. And I love the concept, using sketches and humor to explain complex tech. So, what inspired you to create it?
I guess I was trying to write the book for myself from many years ago,
Mhm.
or from a few years ago. So when I started out, I didn't take a CS program in college or in my post graduation. I'm more of a doubly signal processing guy who happened to learn and enjoy coding along the way. So when I started, there was there are two types of AI books, and I feel like there's still two types of AI books. There's one that teaches people in code, which is
Mhm.
fantastic. So if you're a software engineer, that's your type of book, because if you don't understand an algorithm, you can understand the code and learn the concept. And then there's the other type of book that's more suited for statisticians and people from a mathematical background, which is very beautifully explained in equations and derivations, why things work, and giving you mathematical grounding.
Right.
Neither of these books work for the people in the messy middle, people who
Yeah.
aren't coders or people who aren't from a
Yeah.
mathematical background. And I felt like the few books that were available in that space were
Mhm.
dumbing things down way too much, because when you do that, like the reader loses the ability to make decisions based on that. The concept is so diluted that you get what's happening, but you don't really get anything actionable out of it. So I thought, okay, let me see if I can address it. And
Mhm.
the biggest fears that I've seen people have is that AI is too complex, it's too intimidating. So then I wanted to have something that was less scary and easier to approach. So that was the whole point of having illustrations in the book, doodles specifically, and then being able to explain things in plain English. Because if you're able to do that and you're able to do it without diluting the idea, then you're sort of empowering people to at least speak the same language. We talked about this earlier, right? I mean, a lot of executives, a lot of decision makers, they are under pressure to adopt AI initiatives because their
Yeah.
competitors are, because maybe their board is pressurizing them, maybe they need to raise around. All of these things, it's not easy, right? Being an executive, you're under time crunch, your competitors stock values are going up, and you need to do something. And then
Yeah.
you want to solve a particular problem, and then you don't really understand the trade-offs there. And then you go
Yeah.
to your engineering team, and the engineering team starts speaking to you in jargon and like
Yeah.
KPIs and stuff. There's a
Exactly.
disconnect there. And then on the other side of the chasm, the engineers themselves are frustrated having to explain why something can't be done repeatedly to either their boss or their boss's boss. And there's this fundamental disconnect. So this book is designed to help both sides communicate better and
Yeah.
understand AI in very simple terms without dumbing things down.
Yeah, yeah. I think we need, where it bridges gap between technical and non-technical. And it is such a wholesome origin story, It shows that clarity doesn't have to be dry. And I'm sure those doodles are so clear where what is something you have always done, or did they start as a way of simplifying through tough concepts?
So I've always enjoyed drawing. I'm not great at it, I'll be very honest, but I've enjoyed it. So one of the inspirations, I guess, for this book, actually two inspirations. One are the comics by think his name is Randall Munro, if I'm not mistaken, the person behind XKCD. Just being able to explain a lot of complicated things with just stick figures, right? That's such an amazing superpower, honestly. And
Mm.
the second person who inspired me was this mathematician called Ben Orlin, and he has this book and blog called Math with Bad Drawings, and it's really hilarious, but actually the ideas stick with you well after you've read
Right.
something. That was sort of like I was trying to find a way to explain ideas because let me give you an example, right? If I tell you embeddings, you probably have an idea of what they are. But then if I'm telling an executive like these two are close in the embedding space, these two concepts, they have no idea what an embedding space is. They don't know what close means. But if instead I draw a graph
Mm.
and I have two dots on the graph and I say this is one concept, this is another concept. See how they're close in this graph. That means they're in the embedding space, they're close together. And then see these two other things, they're far apart. That means they're
Yeah,
very different. That image stays with you longer
absolutely.
than paragraphs and paragraphs of text about cosine similarity and all of those things. So
Yeah, yeah.
that's that is the reason for it. Yeah.
Absolutely. Visual approach totally works here. You remember it faster and you can relate things here. So, is there one analogy from the book that people really latch onto? That moment where AI suddenly makes sense?
Definitely, I would say like the embedding one is quite popular, but it's not an original analogy, to be honest, like graph paper and all of that. That's something that others have also used in the past.
Hmm.
Original analogy, I think it's tricky, but I would actually maybe say there was something around the generative model. So again, I want to caveat it because a lot of the community says generative AI and they talk only about LLMs, but there's an
Yeah.
entire series of vision related models that are also generative. So I think there's this analogy I used for explaining a variational autoencoder, and I think that was probably something where beta readers who maybe read the book early on, early drafts of the book, I think that was the feedback I got. It's like, this is I instantly understood this.
Yeah.
And the other one that is quite that people really enjoyed was the one for GANs. Like you can generative adversarial networks, right? You can reframe it as a cop and a thief trying to
Yeah.
outsmart each other, and then that idea sticks to you. So there's plenty of examples like that. But yeah,
Awesome, awesome. I love that. It's such a clear mental picture here. Those analogies stick better, than any formula sometimes. And personally, do you use sketching to think through systems, kind of like visual debugging here?
a lot of times, to be honest,
Hmm.
because I find that one sketching and writing in general is always it always clarifies my thinking. I really enjoy doing it, whether or not that sees the light of day.
Yeah,
But just to think through ideas, pause and slow down, because in this age especially we have these extremely smart but sometimes stupid assistants available to us 24/7
yeah,
and it's the temptation is like too high sometimes where you say okay I need to figure this out. Let me ask ChatGPT or let me ask Claude and
exactly.
see what it says. But I feel the value is really in you trying to solve the problem first. So slowing down and so going analog, writing things down or drawing things is my way of forcing myself to step away from the keyboard and actually think through things. And I might not get the answer, which is fine, but at least I've thought through the problem.
Absolutely, absolutely. And that's brilliant. Turning thinking into drawing is such a underrated engineering skill, I think. And I think we should utilize that. And a
You
lot
don't
of
need to be good to draw, by the way. I'm not.
Yeah, yeah. A lot of people still see, AI as a mysterious or, intimidating. How do you help them realize it's not magic? It's a patterns, data, and thoughtful engineering.
That's a tricky one depending on who I'm talking to be
Yeah,
honest. Because for some people, I mean, like even for us, right? Just think about it. 3 years ago, this whole notion of smart chatbots,
yeah,
it was non-existent. I mean, the the customer support agents that were automated at the time were terrible, and then like from that to come to where we are now, and then complaining that these models aren't good enough or this release isn't as good as the last one. I mean, like we've been spoiled for choice. So I do find that magical, to be honest. But I guess the idea is like trying to explain to people that, especially neural nets, because people keep saying they're black boxes and they are
yeah,
to some extent because it's but then just walking people through the process of how things learn and why it works. So machine learning itself is learning rules from data, so starting there and then giving examples like okay, how would you like very simple examples like how would you search for something or how would you filter
Right.
spam, or how would you do translation, and then
Yeah.
trying to show them that the model is trying to pick this up from each of these aspects in the data, and then slowly working my way, so one idea at a time, and then after that actually showing them where it fails, because that's when the whole Wizard of Oz curtain comes down. Because if you only show the strengths of something, they'll be like, wow, this is amazing, but then you
Yeah.
show them the limitations, they'll be like, okay, I see where it fails, and then that brings them back to reality, in my opinion.
Yeah, yeah, absolutely. And the magic, disappears once you peek under the hood. And but that's when the real aspect for the craft begins. And let's shift gear here and let's talk about what is happening in AI right now. Everyone is
Hmm.
talking about AI agents, but technically it's more subtle. It's about connecting multiple agents, systems that can reason, plan, and act in loops. So sometimes they use tools, or there are APIs. They even talk to other models as well. So what's your take on AI agents today? This is at a very early prototypes, or are we starting to see systems that are genuinely reliable?
I would probably say in the earlier end of the spectrum, to be
Mhm.
honest, from my perspective. And there are workflows where you see AI agents actually doing really well and helping out. And it's but like real, but trying to say that you have fully autonomous, quote unquote, artificial employees who can handle any task, any context, any setting, 100% reliability, that is high. I
Yeah,
don't think we are there yet. If we are there, like, it might be some company working in stealth, but I don't think we are there yet.
exactly.
But where we are is a lot of the tasks that LLMs previously struggled with, because they were the ones doing all of it. Like whether it's the calculation, whether it's the generation, whether it's the planning, all of it, everything was in like single point of failure. And now you've created this separation where the LLMs are responsible for planning, quote unquote, reasoning. I want to be very careful when I say reasoning, and deciding what the next steps are, and then offloading all of the stuff it's not particularly good at, like calculation, booking things, and
Yeah,
those parts, giving it access to tools.
absolutely.
That's a smart design, and then
Yeah,
that has empowered a lot of use cases. So that, to me, has been the progress right now. Just infrastructure that's been built around giving tool access, and then learning to use those tools, and then closing the loop, and then
yeah,
deciding what is the right way to use those tools. There might be many ways to solve a problem, and then
right.
trying to figure out which is the most efficient way. Those are the areas where I feel like work is actually being done. But
Yeah,
in terms of fully, I can replace X people
yeah,
with agents, I don't think we're there yet.
absolutely. Makes sense. Earlier people were saying 2026 will be a AI agent, and then now they are saying it's a context engineering and it keeps changing.
I think Karpati said it really well, right? Andre Karpati. And I love the fact that he's very, like, his takes are usually
Very organic and very,
very well thought out, I feel. And he said it's like the decade of agents or something like that. If I'm not mistaken, in a recent interview, he said it's a
yeah,
decade of agents or something, which is
exactly.
more reasonable, because it's not like 2026, okay,
Yeah,
we've solved agents, now what's next?
yeah,
I'd be very gobsmacked if we actually got there. But I feel like it's a much more revolutionary or iterative process as it's always been. We will see leaps and bounds, but I don't think 2026 alone will be the year of agents.
absolutely. And we, as you said, we are at a very early stage here. I like that perspective. The idea that agents might quietly become the backbone of many workflows. Even most users never see them directly. So that's still there. So, Sairam, you share so many great AI learnings resources online. For some just getting started, where should they begin? Math, code, project. I see so many great resources you have on your LinkedIn. So, how do you
Um,
think?
it depends on their background, to be honest, and what their interests are. So
Mhm.
if you are just interested in learning about the field, like if it's more of a curiosity thing and you don't come from a software or
Absolutely.
mathematical background, just read up on books that are related, that are explaining these ideas or talking about the implication of these ideas. There are books that even talk about the application, like how there's
Mhm.
this uh, I forget the title, but it was very very fascinating to read it. I'll probably try to send you the link afterwards, but it was basically drawing a parallel between how the human brain evolved and how AI has been going through those same stages as well, which is very very well written, to be honest. But that doesn't need you to know mathematics or coding. And then, shameless plug here, you can start with my book to learn as well. But
Absolutely.
if you're somebody like a software engineer who's trying to break into AI, then you probably want to take books like, again, there's so much to learn in this field.
Mm-hmm.
And the way that I usually recommend, like I share a ton of resources, but I always caveat it saying start with what you need, and then
Yeah,
as you need more, expand. So start with a problem and start with what you need, and start with start learning what you need to solve that problem, and then go deeper as you are further into the weeds. So maybe like a good book on deep learning, like if you want the theory, there's
yeah.
this book by Dr. Simon Prince. It's called Understanding Deep Learning. It's really well written. And then there's a, for the practical side, if you are a software engineer and you have absolutely no background in mathematics, I would say the Fast AI book and course. I would say
Mm.
that that is honestly like the number of people, a number of founders who have come out of the Fast AI program is insane. Like,
Wow.
and they didn't intentionally start out as founders, but they got into deep learning and the way that it was taught. Jeremy Howard, honestly, I thank him enough. Like, start there, start somewhere where it's using your strengths to explain something new to you, right? If you understand code really well, you should go for the code first approach. If you understand math really well, start with the theory and then slowly incorporate code. Now you have again ChatGPT or Claude, where you can copy paste a snippet of code and say, explain it to me. Why is it working? What are other ways this can be implemented? Is this, can this be optimized? Will this work in such and such scenario? How do I adapt it from say text to vision, or how do I adapt it for this problem in text? It's currently being used for some other problem. So you have amazing resources available to you. It's just
Absolutely.
about choosing one that fits your background and your
Yeah.
needs, and then going from there.
Makes sense. Completely. 100%. That's a great advice. And I guess a balance between fundamentals and hands-on practice,
Always fundamentals. Fundamentals first, build that, and then practice, practice, practice. Learn by doing.
Absolutely. And you have mentored a lot of engineers too. So what is the one mistake you see when people jump straight into frameworks like LangChain or Llama Index without understanding the fundamentals first?
I think that it's hard to be an engineer in the AI field
Yeah.
right now. It's always been hard. It's probably never been harder because every
Yeah.
day there's something out. Every day there's something that's going to be the next big thing,
Yeah.
and just separating the signal from the noise is always going to be challenging. So the thing that I see is your debugging skills really suffer if you focus on frameworks. If you say,
Yeah.
okay, I'm just going to call this API, I'm going to connect it with this other thing, and then see
Mm.
I've built a RAG system, or I've built an LLM, whatever. But then if you ask them one level deeper, and I see this in interviews also, right? Like when you ask them one level deeper, how does this work? Okay,
Mm.
why? Let's say that this particular outcome happened. Why do you
Mhm.
think that happened? How would you
Yeah.
fix it? How would you change it so that something else happened?
Mhm.
That's where the entire foundation breaks. Like it's a building that's where the scaffolding is really weak, and then on
Yeah.
top of that you're building all this fancy roof and balconies and everything. It's not going to stand. The moment some kind of pressure comes on the base, it's gone. So
Absolutely.
that's the common mistake, where you are so under pressure because everybody is talking about some new framework, and the
Yeah.
temptation is like just to go and do that versus spending time on the fundamentals and learning the basics. The piece of advice I keep giving is spend time here. Initially you will be slow because fundamentals take time to learn and ingrain, but once you learn it, you can pick up anything new relatively fast. So in the longer run, this will pay off. But just having the
Definitely.
patience to invest the time and energy it takes now to see that
Yeah.
compound interest later on, I think that is the gap I'm seeing quite a bit.
Yeah, yeah, 100%. That over reliance on high level tools without grounding usually it leads to brittle systems, as you said, scaffold might get lost here.
Because
Absolutely.
if you build a solution for your company or a client, and then
Mhm.
later on it breaks and you don't know how to fix it, and your only solution to fixing it is to ask ChatGPT, that's a terrible place to be
Yeah, absolutely. And this is a great point to close our conversation. Thank you for your time. And it was a very thoughtful conversation, technical, approachable, and we started from photography to AI. We almost touch upon so many things and full of insights. For everyone listening, definitely check out AI for the rest of us. I'm just going to attach a link along with this podcast episode, and it's one of the clearest, most human takes on how AI actually works. Thank you
in.
so much for joining.
Thank you so much for having me on. It's a pleasure.
Thank you so much.